Okay, welcome to the first lesson on one and two variable stats, so analyzing stats. And so I just had this quote from Will Smith. We're going to talk about average today, and so I really wanted to kind of address this idea that average really isn't like mediocre. It's right in the middle. Average is something that helps you, uh, but often we think about average as mediocre. So soccer players average speed. Um, we might call it mediocre. And um, so Will Smith is just average. Like average is like right in the middle. But I also like this quote because he talks about work ethic, and it's a really important thing just to remind ourselves that it's something we can control, just how hard we work and doing things the right way. Um, so this is a good video. You can find it from the Joy of Stats, and so you can also find it in the slideshow. But so I'd leave that to you to watch. And so one thing you want to think about is what are the limitations with the concept of average? Can you consider some data where the average might not be a good representation of the data? And so that should come up. So the big idea doesn't change. It's tools from stats are used to critically analyze situations, make informed decisions, and manage risk. Learning goal is using central tendency to describe one variable data set, and the big thing here is going to be comparing two related one variable data sets. So we'll see that today. I can determine mean, median, mode, interpret what those mean. I can draw conclusions. I can explain limitations. So we're going to see like where some of those numbers don't really work that well. We get some neat pictures from mathbaddrawings.com. And then using measures central tendency to compare two related one variable data sets. So measures central tendency, they are summary stats because they summarize a data set. So they are, we call it aggregate numbers, so they're like a summarized number in some way. But the central tendency ones, they're kind of describing a typical value of the data set. So typical, we mean like clustered around the middle. So the mean or the average is calculated by adding all the numbers and dividing by the number of points. It represents all values, so every value counts towards the mean. So here's like a thought about that though, is so you've got this guy, this is from mathwithbaddrawings.com. You got this guy saying what would my average starting salary be? And then he says, I'll put it this way, our average starting salary is $80,000. And so you've got this, again, from mathwithbaddrawings.com. You've got this CEO son that's driving up the average, and so the average is 80,000. Median, the median is the 50th percentile. It's right in the middle. It always tells you that, so it's the number right in the middle. So it could be a single number when the data is in order. If there's odd and if it's even, there's going to be two numbers in the middle, and so we would take the average of those two. So for this set, and when we put it in order, 9 and 11 are in the middle, so 10 is in the middle of those, the average of 9 and 11. So again, from mathbaddrawings.com, so why should I invest with you? Well, not to brag, but my fund has a median gain of 8% per year. So you can see all these years where they're up and down. But if we look at 3, 6, 7 years positive, 3, 6 years negative, he's kind of looking at all of the median number being that one in the middle, any one of these that are around 8%. That's the median. And so again, you can see where the data doesn't the median doesn't necessarily tell the whole story. These are big losses. Mode or modal interval. I like the concept of modal interval. The mode is the data point that shows up the most. If a data set's discrete, there could be data points that share the same value. If all data points are unique, there is no mode. If there's a tie, then all the values that are tied become the modes. So remember, like we have, if we had two dice rolled, the outcomes would be 2 to 12, and then they would come up 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1 ways. So it's the number 7 that shows up 6 times, and so 7 is actually the mode. If 7 wasn't there, and just 6 or 8, so 6 or 8 would be the mode because they're tied. They're both tied for 5. Mode is most useful when we're looking at nominal categorical data. So data that's put into like groups, so like a political party of choice. Um, that's then it matters what number comes up the most or what data point comes up the most. Um, it's doubtful when you're looking at like a big number that you're going to get the same number twice. So looking at population, for example, um, so even though population is a discrete number, it's really doubtful that two countries have the same population. And even if they do, like saying that and saying that's the mode isn't really helpful. So the modal interval is actually better, like when we actually group the data in intervals. So if we could group the data into like, okay, well, all these countries are between 30 and 40 million, that's more interesting. So that's the biggest group. Um, and so if a data set's continuous or that it just really has like a wide range of values, many different values like in population, um, it's not really expected that two data points are the same. And so it's more useful to look at the modal interval. And so I'll show you when we jump to the spreadsheet how to actually get the modal interval. So here's a mode, talks about modal interval. So my modal category 70 to 80. It's got two tests, 70 to 80, again from mathbaddrawings.com. Then all the others are below that. So some averages and limitations. So I just invite you to think about a number that really would be effective, where the mean would be effective, where the median would be effective, or where the mode, or where they're not effective. So give yourself your own example. And so one of the things you could think about is how do big numbers kind of pull these numbers to make these numbers less effective. Calculating measures. So this is some data about from this website here down here. It's the number of people that number of LGBT people that have held office in the country, and the first year that an LGBT person held office in that country. And so when I jump to the spreadsheet, we'll talk more about this one. And then again, we've got two classes, so comparing two data sets. We'll jump to the spreadsheet, we'll talk more about this one. And so here's some examples, and here's a neat question to think about. So if you had to choose to put the median or the mean on the report card, which one would you pick? And so the Ontario provincial report card has the median beside. And so which one would you choose? Why would you choose median or mean? And think about it. And so then here's some multiple choice questions just to think about, some true or false to help you kind of review